Till yesterday, we have been doing relations. Yes or no? So you must have practiced few questions from relations from the NCERT also, which I have told you. Now, we will start today with functions. All right. First of all, any doubt in relations topic? Tell me. Any doubt in relations? So now let's start with functions. Fine. Starting with a definition. Functions. So what is a function? Function is a kind of relation, or I should say, function is a type of relation from a non-empty set A to another non-empty set B. Function is a type of relation from a non-empty set A to another non-empty set B such that each and every element of set A has a unique image in set B. So function is a type of relation from a non-empty set A to another non-empty set B such that each and every element of set A has a unique image in set B. Now, the important words here are each and every. Each and every element. And as a unique image. Each and every element of set A has a unique image in set B. Am I clear? So function is a type of relation from a non-empty set A to another non-empty set B such that each and every element of set A has a unique image in set B. Let us take an example from a mapping. Like this is your set A and this is your set B. Say there are elements 1, 2, 3, 4, 5. Here are elements say 2, 4, 6, 8, 10, 12. Now what happens if it is a relation? Relation is any subset of A cross B. Like if I connect this, 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 and this. Like it is having elements 1, 2, 1, 4, 2, 6, 3, 8, 3, 12. So this is what? This is a subset of A cross C. So it is a relation. It is a relation. When would it become a function? So to make it a function, the mapping should be something like, say this is your set A, this is your B. There are elements 1, 2, 3, 4, 5. There are elements 2, 4, 6, 8, 10, 12. Like 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 12, and image of 5 say is 8. Now, this is the mapping of a function. This relation is a function. Why so? First of all, each and every element of set A has an image. Image of 1 is 2, image of 2 is 4, image of 3 is 6, image of 4 is 12, and 5 is 8. So every element has an image. Secondly, every element has a unique image. Why so? See, 1. In the above diagram, if you see, in this diagram, 1 is having two images, 2 and 4. So image of 1 is not unique. It is having two images. So that is why this relation is not a function. But here in second mapping, you see every element has only one image. So this relation will be a function. We defined it like it is f. So we write it f from A to B and f of 2, f of 1, f of 1 means in this function, if you put 1, what do you get? You get 2. F of 2. If you put 2, what do you get? You get 4. F of 3. If you put 3, what do you get? 6. F of 4 is 12 and f of 5 is 8. Am I correct? So this is what we say f from A to B. तो आप सबमिट कर दो टाइम में. Got it? So image of 1 is 2, 2 is 4, 3 is 6, 4, 12, 5, 8. Got it? Now, what kind of mappings are not functions? Say this is set A. This is B. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12. If you make a mapping like this, mapping, not the mapping of a function. Not the mapping of a function. Why so? 4 is having two images. So, not a function. If I make a mapping like this, like this. Again, not a function. Why so? Because element 5 does not have an image. Element 5 does not have an image. Am I correct? So element 5 does not have an image. So this is also not a function. Understood, everybody? Any doubt? No. Domain of a function. Write down domain of a function. So this is what the values of x which a function is capable of absorbing, I should say, absorbing is called a function. Values of x which a function is capable of absorbing is called a function. Am I clear? Which a function is capable of absorbing is called a function. Or values of x defined for a function. Like if I write function f defined from a to b. So this entire set A, this is what we call domain. This entire set A is what we call domain. And here this entire set B, this is what we call codomain. So what is codomain? Codomain is if a function is defined from A to B, then set B is called codomain. Am I correct? If a function is defined from A to B, set B is called codomain. Then there comes range. Range is what? Set of images of the elements of domain set are called, is called range. Means whenever the domain values are placed into the function. So whatever do you get is called range. Now say a function f is defined from A to B. The mapping is like, this is your A, this is your B. Here elements are 1, 2, 3, 4, 5, 6. Here elements are 2, 4, 6, 8, 10, 12, 14, 15, 16. Function is defined from A to B. F is defined from A to B. Mapping is like 1 goes to 4. Image of 2 is 6. Image of 3 is also 6. Image of 4 is 10. Image of 5 is 12. Image of 6 is 16. Got it? So domain is what? Domain is entire set A. That is 1, 2, 3, 4, 5, 6. Codomain is what? Codomain is entire set B. That is 2, 4, 6, 8, 10, 12, 14, 15, 16. Correct? Now in this function you see f of 1 is going 4, f of 2 is going 6, f of 3 is also going 6, f of 4 is going 10, f of 5 is going 12, and f of 6 is going 16. So what are the images? Image of 1 is 4, image of 2 is 6, image of 3 is 6, image of 4 is 10, image of 5 is 12, and image of 6 is 16. This set of images is what we call a range set. So range set is going to be what? 4, 6, 10, 12, 16. Am I clear? So this is what we call range set. So now there are three terms: domain set, which is the entire set A, codomain set, which is the entire set B, and range set, that is the set of images. Am I clear? Now, few important functions. Few important functions. So we'll talk about some functions. First is identity function. Like there was identity relation, now there is identity function. If domain and range are same, and each element of domain set has image itself, or I should say domain set is image of itself. Is image of itself. This function is generally fx equals to x. So this is what we call identity function. Graph of this function is like this. Got it? Like if I say set A is say 2 to 6, and f from A to A, I say fx equals to x. That means the graph will be like what? The graph will be something like this. From 2 to 266. This is what we call IA. And this is what we call identity function on set A. Identity function on set A. Understood? Now, second type of function that comes into picture is polynomial functions. Polynomial functions. So simply what? Functions of the type of fx equals to a naught x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2, and so on a n minus x plus a. So functions of this type are called polynomial functions. Their domain is always x belongs to R. You can put anything into them. Domain is always x belongs to R. Polynomial functions are called, their domain is always x belongs to R. Now see, as an example, if I see fx equals to 2x minus 7 by 2. This is what we call linear polynomial. Fx equals to x cube plus 3x plus 1. This is what we call cubic polynomial. Fx equals to 3x to the power 5 plus 7x square plus 11x plus 2. This is what we call fifth degree polynomial. Now in all the cases, domain is what? Domain is x belongs to R. In all these cases, domain is x belongs to R. Correct. And range is what? Range is also R. All the odd degree polynomials, their range is also R. Understood? But if there is even degree polynomial like x square plus x plus 1, or fx is x to the power 4 plus 7x plus 2, domain no doubt, again x belongs to R. But range will be a subset of R, but never complete real number R. So in case of even degree polynomials, range will always be a subset of R, but never the entire R. Understood? Understood? See, my device is like this. I cannot read your chats. So either you speak up or I will also sit silent the way you are sitting. Today, let us sit silent. Today, I cannot read your chats. So you have to open your mic and say yes or no at least.
Yes, sir. Yes.
Yes, sir.
Now, how to find the range of a quadratic polynomial? Now, if we're trying to find the range of a quadratic polynomial, we are aware that either its graph is like this or the graph is like this. Now, this happens while a is less than 0. This happens while a is more than 0. Now, this top notch point, this point is minus b by 2a and minus d by 4a. And this bottommost point is minus b by 2a minus d by 4a. Got it? So if the parabola is like this, range will be minus infinite to minus d by 4a, phi coordinate. And if parabola is like this, range is minus d by 4a to infinite. Got it? Except this, there is a way also. Like if you assume y equals to 3x square plus 7x minus 4. Y is 3x square plus 7x minus 4. If I go with the formula, this is this kind of graph. So range will be what? Minus d by 4a to infinite. Now d is b square 49 minus 4, a is 3, c is minus 4. So it is 49 plus 48. That is 97. So range comes what? 97 to infinite. Oh, sorry. D by 4a करना है ना? We have to do d by 4a. So range is 97 by 6. 4a, 12. 97 by 12 to infinite. Understood? Now there is another method also. The quantity given to you is y is 3x square plus 7x plus 4. So it will be 3x square plus 7x plus 4 minus y equal to 0. 3x square plus 7x plus 4 minus y equals to 0. For this quadratic, do d more than equal to 0. So it is b square 49 minus 4, a is 3, c is 4 minus y more than equal to 0. 49 minus okay, this is minus 2. So it is 49 minus 4 minus y. So 49 plus 48 plus 12y more than equal to 0. Correct? It is minus d by 4. No? So 12y more than equals to minus 97. So implies y is more than equal to minus 97 upon 12. Am I clear? So this is how we find the range of quadratic polynomials. For linear and cubic, we already have an idea that their range is always R. For fourth degree and onwards polynomial, they're getting the exact idea for the question is not easy. And it may vary depending upon the question. So if we come across some question, we'll go through it. Now there comes Any doubt up to this point?
No, sir.
Write down a simple question. Find the range of fx equals to 3x square plus 4x minus 3x square plus 4x minus 5. Yes, do it quickly. Yes, quickly do tell me the answer. Nineteen by 3. What is the exact answer, Priya? It is 19 by 3 to infinite or minus infinite to 19 by 3. What it is? Now again same. First of all, since it is a downward opening parabola, range will be somewhere between minus infinite to this top notch point. Minus infinite to minus d by 4a. Fine. If I go with the method, so it is y equals to minus 3x square plus 4x minus 5. So 3x square minus 4x plus 5 plus y equal to 0. Now for this quantity d more than equal to 0. So b square 16 minus 4, a is 3, c is 5 plus y more than equal to 0. 4, 4 ja. So it is 15 plus 3y less than or equals to 4. 3y less than equals to, just a moment, just a moment, just a moment. That has to be b square minus 4ac. So b square minus 4, a is minus 3, and c is also minus, c is 5 plus 5. So it will become positive. So it will be 19 plus 3y more than equal to 0. So 3y there's some mistake happened. 3x square plus 4x 16. Okay, I have already managed it. So it will be 3x square 4x plus 5 plus 5. D more than equal to 0. So 16 minus 4. A is 3. B is 5 plus y. More than equal to 0. So 16 minus 16 minus 12y more than equal to 0. So 12y less than equals to minus 44. So y less than equals to 40 minus of 44 by 12. That means y less than equals to minus 11 by 3. So your range comes minus infinite, say minus 11 upon 3. Am I clear? Is it okay? Once again, I just assumed it y. Then took this entire expression to the left side. So it came out to be 3x square minus 4x, 3x square minus 4x plus 5 plus y equal to 0. Now its d should be more than or equal to 0. So b square 16 minus 4, a is 3, c is 5 plus y more than equal to 0. 16 minus 4 3 is 12, 5 is 60 minus 12y more than equal to 0. Understood? So I can say that is 12y is less than or equals to minus 44. So y is less than minus 44 by 12. So y is less than 11 upon 3. So your range belongs to minus infinite, say minus 11 by 3. Understood? Now, the next variety is rational algebraic functions. Rational algebraic functions. Functions of the type of fx equals to 2x minus 3 upon 3x plus 1. Okay, that is of linear upon linear type. Or fx equals to 3x plus 7 upon x minus 5, like this. That is x minus, say x square minus 5. Linear upon quadratic type. Or fx equals to x square minus x plus 1 upon x square plus x plus 1. That is quadratic upon quadratic type. They are called rational algebraic functions. Means polynomial upon polynomial type. So they are called rational algebraic functions. Now, what happens? Their domain can be calculated for every x belongs to R minus all the x at which denominator is getting 0. This will be their domain. Like if I have fx equals to 2x minus 3 upon 3x plus 1. So domain is what? X belongs to R minus. Now the denominator is getting 0 at which x? Minus 1 by 3. So minus 1 by 3. This is the domain. If fx is x plus 5 upon 2x minus 3. Domain is what? R minus 3 by 2. Matlab the x at which denominator is getting 0. If fx is x square minus x plus 1 upon x square minus 3x plus 2. Now see, if you factorize the denominator, you get the roots as 1 and 2. Means at 1 and 2, this expression will be not defined. Its denominator will be getting 0. So in that case, domain is what? R minus 1, comma 2. This is the x, these are the x 1, comma 2, at which denominator is getting 0. Am I clear? Now, let's come to range. Range of rational algebraic functions. Range of rational algebraic functions. Range of rational algebraic functions. So if there is a function fx equals to say 2x minus 3 upon 3x plus 1. Now how to find their range? So we'll do step-by-step process. Step 1, put fx equals to y. So you get y equals to 2x minus 3 upon 3x plus 1. Before that, if I write its domain, domain is x belongs to R minus. Now what is x at which denominator is getting 0? Minus 1 by 3. Am I clear? Mahesh Babu, are you getting it? Dhanush?
Sir.
Fine?
Yes, sir.
Now to calculate range, write y as 2x minus 3 upon 3x plus 1. Then step 2. Cross multiply and write x in terms of y. So it is 3xy plus y is 2x minus 3. So x into 3y minus 2 is minus of y plus 3. So x is minus of y plus 3 upon 3y minus 2. Now see here, y can be anything. See at this. Y can be anything except 2 by 3. So finally you say range y belongs to R minus 2 by 3. Have a look. Understood? So let's keep a pause here only for today. And let me revise things for you first. So we started with function. Function is a kind of relation or type of relation from a non-empty set A to another non-empty set B, such that each and every element of set A has a unique image in set B. Now then I told you like this is the mapping of a relation only because element 1 is having multiple images, element 3 is having multiple images, elements 4 and 5 are having no images. So this is just a relation. And what is the mapping of a function? Where each and every element has a unique image. This is what we call F12, F24, F36, F412, F58. Now, this is not a mapping of a function because element 4 is having two images. This is not the mapping of a function because element 5 is having no image. So this is how we see when a function, a relation is a function and when not. Then domain. Domain is the set of values of x which a function is capable of absorbing. And after absorption, it is capable of providing certain output. So this entire set A is what we call domain of the function. The entire set B is called codomain. And the set of images, like after putting the domain values, whatever do we get, it is called range set. The images of the elements of domain set is called range set. Like here, domain is what? 1, 2, 3, 4, 5, 6. Codomain is what? 2, 4, 6, 8, 10, 12, 14, 15, 16. But range is 4, 6, 10, 12, 16. This is their range. Identity function I told you, simply y equal to x function. Then polynomial function is this kind of function. The polynomial we have been doing since our 8th, 9th class. Linear polynomial, cubic polynomial, fifth degree polynomial, their domain is always R, range is also always R. But the quadratic polynomial or any even degree polynomial, domain is R, but range will never be R. Now, in case of quadratic, range is minus infinite to minus d upon 4a. Or minus d by 4a to infinite if it is upward opening parabola means a positive. Then we have done few questions on parabola. Range we have done, then we came to rational algebraic functions. Simply linear by linear, linear by quadratic, quadratic by quadratic, or any polynomial by polynomial, they are called rational algebraic functions. Maximum this variety will be our concern. Their domain is always what? R minus all those x at which denominator is getting 0. Then we have done equation for the range and that happened all. Anybody having any doubt, any issue, let me know quickly. Please, anyone? See, I'm very disappointed today. You did not talk